How to Feed 7 Billion Part 2. We finished the last video off with the extractive industries. What we did not identify is just what they are. Yes, it's pretty self-explanatory. You got it from before. But the mineral fuels, fossil fuels that we extract out of the ground, oil, coal, natural gas, those things. It does not include agriculture or aquaculture. So it fits in with our unit because it's rural land use, but it's like a little asterisk footnote because it is rural land use, but our focus primarily has been agriculture. But that's okay. It still fits in. We should still be aware. Okay. So all of that last video was about how to increase agriculture by expanding land. The other option is to use the land we already have, but increase the productivity. And that's where the Green Revolution comes in. If you remember those 3 agricultural revolutions throughout our history, the first one about 15,000 years ago, the second one around the Industrial Revolution, and the third one referred to as the Green Revolution, where we start using genetically modified organisms, or GMOs. We use science in a lab to modify the genes of different crops, of animals, to increase their yield. We can go ahead and splice a certain gene out of one type of plant, put it into the gene of another type of plant to get things to grow bigger and grow faster. Another way of increasing productivity is with fertilizer. And scientists have kind of broken down the 3 main components, the big 3 components for fertilizer to increase the growth and yield. And that's going to be nitrogen, potassium, and sodium, phosphorus. Sorry, couldn't remember the K. But nitrogen, phosphorus, and potassium. They're the 3 chemicals that help plants grow more than any other. It restores that depleted soil. And so, while here in Wisconsin we rotate our crops between between corn and soybeans, the fertilizer also helps keep those crops fertile, or the soil fertile. And really, under traditional crop rotation, there is a time period where you would have to leave a year or 2 of just nothing growing, just for that land to rest. With fertilizer, you no longer need to do that. Problems with artificial fertilizer, these big 3, is that it's very simple. It takes something and just breaks it down into these 3 main parts, components, but you go out into nature and there is nothing that is that simple. When you look at the best soils in the world, it's not because it's rich in just these 3 things, but because it has very rich humus. Humus, which is the organic topsoil that contains billions of big and small organisms both. It has bacteria, it has phages, it has fungi, it has worms, etc. All of these things that make the soil rich. It's very, very complex. It holds lots of nutrients. It holds additional water. It holds additional air. All of these different components that help in the growth of plants. And we try to break it down into just 3 main parts. And many people that are against the use of artificial fertilizer will argue that it's way too simple and it cannot replace the complexities that nature provides originally. So this humus is richer than any fertilizer that we have been able to create in a lab, and it is 100% natural. Just the natural environment is very, very complex, and it's identified in this humus, this very dark, rich, black soil. Okay, and so this leads to the tragedy of the commons, which is just a basic idea that we know that artificial fertilizer is not the best. Okay, we know that there's different things that can be better. However, we're going to go ahead and act in our best interest, even if it's harmful to others. The fertilizer makes it profitable, so farmers continue to use it, even if it's not the best for the environment. It contaminates streams, runoff. You think of the amount of fertilizer that farmers put down, and normally they over-fertilize. Same thing if you look at Wisconsin in the wintertime. We throw salt all over the roads. We throw salt on our driveways. We throw salt on the sidewalks because we don't want ice to form. We don't want to freeze. But what happens when everything thaws out and that salt gets mixed in with the melting rainwater. It runs off. If it goes into the stream, I remember living when I lived close to Phantom Lake, everybody throws salt on the roads, salt on their driveways, and then in the spring when it rains, that salt goes with a runoff into the road, into the gutters, and it runs down right into Phantom Lake. And so all that salt we're throwing on our roads is going right into Phantom Lake. If you don't live by the lake, all of that soil or salt is going into the soil. And we identified in the last video the dangers of too much salt in the soil. Now, generally, yeah, 1 year, you throw salt down a couple of times, it's not going to be that big of an issue. But if communities do this year after year after year, what is that impact going to be? Same idea when you look at the use of fertilizer. It contaminates groundwater as it trickles down into the soil with the water, and it also contaminates streams as runoff. If you think about corn, where corn is grown, we throw all kinds of fertilizer, excess nitrogen, into the soil because corn uses so much nitrogen. As a result of that excess fertilizer, as it rains, that fertilizer that was sitting on the soil now gets picked up and runs off with the water. And as it goes into small streams, those streams go into larger rivers, into the large river system. And here you're looking at the Missouri River system, you're looking at the Arkansas Red and White River system, Upper Mississippi, Ohio, Tennessee. They all flow into the same area, the Mississippi River. And all of that flows into the Gulf of Mexico. And so we're getting all the extra fertilizer from the Great Plains, from Minnesota, from Wisconsin, from the Ohio River Valley, Tennessee, and all of that extra fertilizer is running into the Gulf of Mexico, which has created a dead zone. All this fertilizer has gone in and helped stimulate the growth of algae, red algae, and algae is just sucking in the oxygen from the area, which is preventing fish from being able to live. And so now we have this large dead zone just south of Louisiana in the Gulf of Mexico where no fish are able to live because of our fertilizers. The groundwater becomes very high in nitrates, making our drinking water in some cases unsafe. When you buy a home, one thing that has to happen is you need to test the drinking water. It's required. It blew my mind when we were having a kid, and we went to visit my parents, and they said, "Oh gosh, Mark, don't let Brenda, my wife, don't let her drink any of our water." I grew up there drinking all of that water, but because it was surrounded by farmland, there are 40 years, 50 years of nitrogen being put onto the soil to fertilize the corn, and that has trickled down into the drinking water, and the level of nitrates is way too high and is dangerous for pregnant women to drink and for babies to drink. And so this encourages the idea of sustainable land use, models that only use resources that can be replaced. So if you're using trees, you plant trees to offset carbon emissions. And this preservationist land use model preserves the resources no matter the cost. Okay, so if you got something that is limited, you just don't use it. Doesn't matter if you need to grow something there, you don't use it. Okay. Sustainable agriculture is the agriculture that preserves and enhances environmental quality. It has a lower revenue, okay, and lower cost. So you're not bringing in as much money, but you're also not spending as much money with sustainable agriculture. In other cases, they choose to replace a product that is harmful to the environment with a more environmentally friendly product. That fits in with sustainable agriculture. This video clip I'm not going to hit. You can go ahead and check that out. But Milwaukee was an example for urban sustainable agriculture and how urban environments were able to increase agriculture for the people in the area. When you get back into rural areas, ridge tilling is a process of planting crops on the ridge tops. This is done to reduce erosion. You don't need to use plows, and so you're not stirring up the soil, because every time that you stir up the soil, you're losing nutrients. This is going to cost less money for tractors. They use less gasoline, less oil, because they don't need to go over the land as often. It results in richer soil quality, more organic material being present in the soil, which has more earthworms, which is returning nutrients into the soil and holding more water. Here's an example of kind of what ridge tilling looks like. Before planting a new crop, you have the ridges, and then you go ahead and you just skim off the top, put the seeds in the ground on the top of the ridge, and you let that to continue to grow right there. On the sides, you have the older plant material, which has gone down and is decomposing to create fertilizer for the plants that are growing now. And then you have businesses such as Chipotle, which make efforts to have sustainable agriculture in the products that they purchase. This is a video clip on no-till agriculture. Really, it's a full-out documentary. Knock yourself out. But farmers that attempt to never disrupt the soil. You can see all of the old foliage from the old plants and old crops being left here to put nutrients back into the soil. Okay. You plant and you harvest only. You don't need to be doing other things. You're not stirring up the soil. You're not damaging the organic material that's there. In which case, another way of kind of working with sustainability in agriculture is limiting the use of chemicals. We now, through genetically modified organisms and genetically modified foods, we have Roundup-ready corn. Corn that we can spray with Roundup, which is a herbicide which kills plants, but it doesn't kill corn. And so that will go ahead and make sure that you don't have any weeds in the area. The other effort that people go towards is organic. But what is organic? It was started by the Robin Hood Commission during the 1970s. They seized a vacant lot in San Francisco at People's Park to create a cooperative society of uncontaminated food. Essentially, their fight was against Monsanto, a chemical DDT herbicide company that was also producing Agent Orange, a herbicide that was being used in Vietnam. The goals was to have chemical-free agriculture, having an alternative distribution, so cooperatives all around the country to reduce carbon emissions, and alternative consumption, reduce processed foods. That was the goal. The reality is the government has to define what organic is, and so chemical-free agriculture is part of organic. Alternative distribution co-ops is not part of the definition anymore, and neither is alternative consumption. So organic by government standards, it's chemical-free. You have industrialized organic farms. An example is Cascadian Farms, where they produce organic TV dinners, which seems very odd, very backwards for an organic movement. Okay. The homework with today's reading is a reading about polyface farms coming out of the book The Omnivore's Dilemma, which is an excellent book about our agricultural system. It's divided into 3 parts. One is commercial agriculture, the second is kind of the small farm agriculture, and third is hunter-gathering, not of hunter-gatherer societies, but people that hunt their own food, that go around scavenging for asparagus out of the ditches and mushrooms in the forest that they use to make their meals. So the reading is available on Schoology, and that is the homework assignment students are getting at the end of the day. Thank you.